Okay, the next half of this section very much continues with these areas. You really don't have to graph those, but marginal analysis and exercises 47 through 52. Find the change in cost, revenue, or profit. For the given marginal function, in each case assume that the number of units increase by 3 from the specified value, which means this is going from 10 to 13. This is going from 500 to 503. And this is going from 125 to 100 to 125. 28. So, if they gave me the marginal revenue in this case, right? The marginal cost in 48, revenue in 50, and marginal profit. Well, to figure out the change in the cost, that would be the integral from 10 to 13 of 20,000 over x squared dx. And if you notice how we did this before, when we did this from 10 to 103, we cross-multiplied and we integrated to figure out what the actual change is. Then we figure out the change at 13, the change at... This is pretty much the same thing. The change in the cost is really, this is, let's see, the integral of 20,000 is a constant. I can ignore that, right? So this is x to the negative 2 dx. The change in cost between 10 and 13 units would be 20,000 times, isn't that x to the negative 1 over negative 1 from 10 to 13? The change in cost will be negative 20,000 into 1 over, plug that in, that's 13 minus, plug that in, that's 1 over 10. And the change in cost would be keep in mind, if you say this is f of 13 minus f of 10, that is pretty much what this is. That's the notation for it normally. And if I get my calculator out and I get a negative 20,000 into 1 divided by 13 minus 1 divided by 10, the total would be 400. What was that? $461.54. $461.54. And that's pretty much how it works. So it's the same as, you figuring out the cost function, you integrate, and then figuring out the cost of 13 minus the cost of 10. Pretty much that does it one shot. And if I look at number 50, the marginal revenue from setting 500 to 503 units, well, we will say the actual, so really dr is, if I cross multiply, is going to be 75 into 20 plus 900 over x dx. And if you integrate the actual change in revenue, that's when you put the limits. So as it is, it's r, the revenue. If I integrate, this will give me the revenue. But if I tackle 500 to 503, that will be the change in revenue from 500 units to 503 units. Not approximate, exact. So what would that be? That is a constant, right? This is, that is a constant. I drag that out into 20 plus 900x to the negative 1 dx evaluated from 500 to 503. I'm going to need a bit more space. And the change in revenue will be 75 times 20x. Add 1 to the, I almost made that mistake. Add 1 to the power, divide by that. That's a special case. Isn't this 900 natural log of x evaluated from 500 to 503? Wouldn't the actual change be 75 into 20 times 503 plus 900 natural log of 503 minus 20 times 500 plus 900 natural log of 500. Again, that's basically f of 503 minus f of 500. And if I plug this in my calculator, I'll get my answer. The total change in revenue over those would happen to be, and we would like 75 parentheses 20 times 503 plus 900 times natural log of 503 I'll tell you how I'm going to do this. It's kind of lengthy. So I'm going to keep the 75 out of it. There we go. So I'll get this part first. Minus 20 times 500 plus 900 times natural log of 500. And if I take that and multiply it by 75, I'll get the total to be 4903.79. 4903 and 79 cents. $4,903.79. And if I tackle the last problem, which is talking about the profit, this is the marginal profit. Well, that means dP is 12.5 into 40 minus 3 radical x dx. And if I integrate, I'll get the profit. But if I integrate from 125 to 128, that would be the change in profit from selling 125 units to 128 units of this function, 12.5. 12.5 is a constant. I could drag that up front. That never affects the outcome. That never affects the interval. You're going to integrate that equation. And the way it works, that's going to be 12.5 times 40x minus, add 1 to the power, divide by that. 1/2 plus 1 is 3/2. Divide by that 2/3. Evaluated from 125 to 128. The change in profit would be 12.5 times. I throw the 125 in. That would be 40 times 128, minus twice 128 raised to the 3/2. You could make that a square root cubed if you want. I'm going to take this minus, when you plug in 125, that's 40 times 125 minus 2 into 125. Again, the calculator will do the work. I really shouldn't be concerned with this. And I'll show you how that works. And how much would that be in dollars? Let me get that calculator out again and let's do this. So I'll leave the 1250 out. If you multiply this by 1250 and this by 1250, it's the same thing. So if I take 40 times 128 minus 2 times 128 raised, I could use the fraction key right there. I'm gonna put division because I'm not sure which calculator you have in case you don't have that key. Minus twice 128 raised to the 3/2. That's the first number. Minus parentheses 40 times 125 minus 2 times 125 raised to the 3/2. I'll get 4, and I'm going to multiply that times 12.5, and I'll get 18,336, and how many pennies? And 63 cents. I just want to make sure I plugged in the first one correctly. The 3/2. Yeah, it's perfect. Okay, good. All right. Now what? Now we have so here, this is the change in revenue from selling 500 to 503 units. This is the change in cost producing 10 to 13 units. So that's the 3 units, those extra 3 units. And this is the change in profit from selling 125 to 128 units. Here, amount of annuity. This formula is provided on your test. You don't have to worry about memorizing that on the test and the final. It says, if C represents a continuous income function in dollars per year, where T is the number of years. This T is the number of years. C represents the continuous income. I'll tell you what that means in a minute. R represents the interest rate. That's normally in decimal. And T represents the term of the annuity in years. Then the amount of the annuity is given by this formula. And there's not much to this formula except you just memorizing, but you don't have to memorize it, so not much to it. They give us all the information that's needed. So what is this for? Annuity. That's when you put in a certain amount and you leave it for many years to go. Retirement, fudge fund, there are all of these different funds you could really use. So if I glance at this, it says find the amount of annuity with income CFD. They tell you what the income is. You're putting in $500 every month. The interest rate is 7%, and you're going to do this for 4 years. How much are you going to accumulate at the end of 4 years? So this is not you putting $500 one shot and waiting for years on it. No, this is you putting $500 every month or year. Let me see. Yeah, every year. I'm sorry. So you're putting in $500 the first year, $500 the second year, $500 the third year, $500 the fourth year. Here you're putting in $2,000 the first year, $2,000 the second year, $2,000 the third, for 15 years. Right? So continuous income in dollars per year. That's what you're input, but that's what you're putting. So you're using this yearly. Well, the amount of annuity, amount of annuity, so let's say AA, annuity amount, would be E to the R 0.07 times capital T times 4. Not much to do here. Not even memorize this. Just plug in. The cost is 500. E to the negative 0.07 times T dt. Right? And if I work this out, let's see how this works. The annuity amount would be, well, this is a constant. You could drag that up front. You could do that every time. Yes, you could. That's times, right? The integral from 0 to 4 of e to the negative. Actually, I could have integrated right there. Annuity amount would be, the 500 is a constant. I drag that. And this is 0.0. I could say 28, or you could just plug it in a calculator one shot if you want. What's the integral of that? That is e to the negative 0.07t. Remember, if I take a derivative, I multiply by that. If I take an antiderivative, I divide by that. I'm going to evaluate that from 0 to 4. So the annuity amount would be a negative 500 divided by 0.07, that's a constant, e to the 0.07 times 4, multiplied by, put a 4 in, that's the capital F of 4, e to the negative 0.07 times 4, minus, if you put a 0 there, e to the 0 is 1, you could put e to the 0, you could just put a 1. And that would tell me the total amount. So, after 4 years, if I was to put a $500 each year. So the problem here is, the tough part, the first 500 is going to accumulate interest for 4 years. The second 500 only for 3 years. The third, so this becomes a bit messy. Calculus allows you to do that. And let's see how we're going to do this. We're going to take this part first. So if I'm doing this, actually no, let's do it as is. I'm going to take negative 500 times e raised to the 0.07 times 4, close parentheses, that's the top, right? Times e all multiplied, so yeah, we're safe. E raised to the negative 0.07 times 4 minus 1 and divide that by 0.07. $2,308, $2,308, 0.7 cents. Okay, so what this means that, keep in mind how much money I put in. I put in 500 each year for 4 years. I really put in $2,000. I'm accumulating $308 in interest. What happened if I put $2,000 a year for 15 years? Well, I'm putting in $30,000, right? 15 years. Each year I put in $2,000. I'm really putting out of my pocket $30,000. How much would I have after 15 years? Keep in mind, here the interest is 7%. Here the interest is only 3%. Well, if I plug in what I have, the annuity amount would be e to the 0.03 times t, capital T is 15 years, times the integral from 0 to 15 years in this case of 2,000 e to the negative 0.03 times t dt. And there it is. Now what? Now I know how to integrate that. That's a constant. I'm going to drag that out. E to the 0.0. Again, you could multiply this, but you could do it on a calculator, right? One shot, times, what's the integral of this? That's e to the negative 0.03t divided by negative 0.03 evaluated from 0 to 15. This amount will be, and if I plug this in my calculator, that's 2000 divided by negative 0.03 e to the 0.03 times 15 times, throw the 15 in, e to the negative 0.03 times 15 minus, if you throw 0 in, e to the 0 is 1. You could write e to the 0 if you wish and let the calculator take care of all of that. Since you're allowed technology, make sure you use it properly. It would be sad to have a calculator and mess up the problem because you didn't input numbers, right? So let's do that. And you could do that in phases if you like. You could say, you know what, let's take 2000 divided by negative 0.03. You could do that. Times e, a piece at a time. 0.03 times 15. Got it. Times parentheses. Oops. Answer times. I should have put times. That would have worked much better. So let me show you again. Again, you get this part, and then you multiply that by e to the 0.03 times 15. If you hit times, it'll take that last answer, and here you need parentheses because you're multiplying it by two things. It's going to be e to the negative 0.03 times 15. Now, the chances of making a mistake is great, so just take your time. Either you put a 1 or you put e to the 0. Work really slowly at this. And there it is. You're going to get a total of 37,887. And how many pennies? If it's money, always round to the nearest penny. 48 cents. So do you see what happened here? You put in 30,000, you're going to get $7,000 more. Right? And that's how you do retirement fund, 401k, all of these extra. Of course, you work backwards as well. We're taking this in one direction. How about capital accumulation? In 71 through 74, you are given the rate of investment. The IDT is the investment. Find the capital accumulation over 5 years. Anywhere you're trying to find an accumulated amount, you're using an integral. We didn't derive it to show you what an integral is literally because we just want to use it. You don't want to go by the theory. So basically, capital accumulation, the total accumulation will be the integral, since you're going for 5 years, 0 to 5, of the change of rate of the investment. On number 72, and this is actually how things work. This is how they determine how much is in each account after a given value. So here, I would say, if I cross multiply, and I'm showing you this so you kind of connect the dots, if I integrate, that would be the actual investment. But I don't want the investment. I want the total investment over, the change in investment over 5 years. So the change in investment over 5 years, you would really run this from 0 to 5. The 100 is a constant. And look how nice and smooth that runs. The change in investment over 5 years is 100 into, isn't that t squared evaluated from 0 to 5? The change in investment over the 5 years, or I should say, the capital accumulation. Okay, maybe that's how I should do it. That's how they defined it, right? No need to even worry about deriving. I don't know why I'm deriving that. They already told us. They want the accumulation capital or capital accumulation. Hey, California. And how does that work? Well, that's easy. That's 100 into, throw the 5 in, That's 5 squared, 25, minus 0. Hey, I don't even need a calculator. There it is. Okay, and oh boy, I got excited, didn't I? Don't you divide that by 2? Oh man. So 100 divided by 2 is 50, and 50 times 25 is 1250. Okay, I got excited there. Don't get excited, you guys. How about this problem? Again, they told me I really don't have to really do much work if I want to figure out the capital accumulation. That is the integral from 0 to 5 of 12,000 t divided by t squared plus 2 squared, right? The 12,000 is a constant. And if I let u equal t squared plus 2, du is 2t dt. And if you recall, that is my u squared. And oops, I almost forgot. I'm off by a 2, that's an easy fix. Divide by 2 both sides. And isn't this 6,000, the integral of u to the negative 2 du? Isn't that 6,000 times u? Add 1 to the power, divide by that. That is negative 600 times 1 over u. Or that is negative 600 times, what's u? U is t squared plus 2. Don't forget, you evaluate that from 0 to 5. So that is need space. That is 600 times 1 over 25 plus 2 is 27. If you put a 0, you get a half. And that's going to be a total of how many dollars? I'll get my calculator out, and I'll take a negative 600, parentheses, 1 divided by 27 minus 1 divided by 2. I'll get a total $277,277.78. Yep. Okay. Another problem I have is number 76. It says, a company purchases a new machine for which the rate of depreciation is modeled by this. This is the rate of, and this is going to run for 5 years. After 5 years, it's not going to worth anything. I mean, this is over 5 years. After 5 years, you don't measure that. Where V is the value. So V, in this case, that volume. It's the value of the machine after T years. T is in years. This T is in years. And V is the value. Very good. Set up and evaluate the definite integral that will yield the total loss. So this is telling you the loss of the machine over 3 years. The total loss in value, we already know how that's going to be. The integral from 0 to 3, that's the change in value really, right? Of 10,000 into t minus 6 dt. That's basically it. So the change of value over the first 3 years is going to be 10,000 is a constant. What's the integral of t? That's t squared over 2. What's the integral of 6? 6t. Evaluated from 0 to 3. The change in the value would be 10,000. A 3 in there. 9 over 2 minus 18. If you put the 0 in, doesn't that get you a 0? So the change in value would be, I could do this by hand, but I have a calculator. Why should I? 10,000 times 9 halves minus 18. I'm gonna lose. The change of value is gonna be $135,000. $135,000. A positive means you are actually making, and a negative means you're actually losing. So we're going to lose 135, and they have to take that into account. You know, this machine could be a new MRI machine. It could be a new scanner for bone, or you know, it's don't think of 135 as too much. Those machines cost an arm and a leg. You know, it could be a printing machine that prints, you know, I don't know how many. It could be anything. The rest of the homework is on page 348. You're going to do 47 to 51 odd and 67 to 79 odd. Just a quick reminder before I go, since I didn't see any problems that I could elaborate on as far as average. If I want to know the average income, the average revenue over 3 years, I will integrate the revenue over 3 years. That will give me the total. And I'll divide it by 3. That's the average. If I want to figure out the average cost, so basically, what I'm saying here, you will figure out the total change in revenue, which is the integral from 0 to 3 of whatever that function is. If I want to figure out the average cost over 5 years, I will figure out the total change in cost over the 5 years, and I'll divide that by 5. That will give me the average cost over the 5 years, you know, per year. Just a hint for your homework, because they ask about an average.